Hello, everyone, and thank you for being here. My name is Apostolos, and today I'm presenting a study we conducted about the utilization of large language models on ontology mapping of healthcare data. The study was conducted in the context of a EU project named Encrypt. So, what was the research question behind this study? Can we actually use large language models to improve the automated mapping of medical terminology to RDF knowledge graphs? And why did we set this question? Because firstly, the manual efforts are costly and slow. Secondly, rule-based systems are not scalable and fail with new conditions. And third, LLMs can understand medical language at scale. Previous work has been done in rule-based systems. One of the most widely used is the BERT map, which is very popular for medical ontology alignment. It has some strengths, such as that it offers interpretable and deterministic mappings. And there are also some limitations, which is about the struggling with synonyms, abbreviations, and contextual meaning. There are also other approaches with the utilization of traditional machine learning, but in many cases with these approaches, we require large annotated data sets in order to have a good performance. And there is limited generalization to unknown medical terms. So, why should we use LLMs? LLMs, or most of the LLMs, the proprietary ones, are trained on biomedical corpora, such as SNOMED-CT, and they enable better contextual term alignment. They adapt to variations in terminology, and they provide more flexible, scalable solutions. In the research literature, we can see that the combination of LLMs and ontologies can improve natural language understanding and medical data standardization. In our study, we used the SNOMED-CT because the simple reason was that it is a widely used medical ontology that provides extensive medical terminology. And previous research shows that LLMs can help improve interoperability. They can used in many ontologies and in different medical terms. So here in the image, you can see an overview of the system that we created. The system actually takes some terms and makes a pre-processing, and then combines a context from a vector database in order to send these two elements to the LLM. And with the right prompts, then the output is a knowledge graph. So the LLM actually handles the semantic interpretation of using change of thought and template-based prompting. The dataset that we used included 48 medical terms from electronic health records of an Italian public hospital. We can see here some examples of the terms. We can see some simple ones, such as age, sex, but also some more complex, such as RET genetics, TNM staging, and residual WBS. The pre-processing steps that we followed was to clean the data and normalize of the terms and deal with synonyms and abbreviations. So after that, we followed the pipeline that we saw before. And as an example, we can see here for two medical terms, the output. So the LLM created the knowledge graph and made an explanation of the term. We can see it as a comment, and also made the connection to the SNOMED-CT. We evaluated the performance of the whole system utilizing the help, let's say, of 4 domain experts who assess the system performance and the property mappings. We can see that from a level of 0 to 5, for all the positive evaluation axes, we have a score above 4, and for the effort, we have a score below 2. So the general feedback of the expert confirmed that we can have accurate core clinical relationships and hierarchical structures with the use of the LLM. They didn't found any major corrections that need to be done, and only minor enhancements. The suggested improvement were to add cross-references to medical terminologies such as ICD, to incorporate temporal constraints in mappings, and also expand the capabilities for unstructured clinical nodes. So what are the conclusions of this study? We can see that LLMs can facilitate medical ontology mapping, and they can provide a scalable solution with increased accuracy. We have also some challenges, of course. The LLMs used to struggle with numeric reasoning and domain-specific jargon. And of course, in many cases, computational cost and API dependency can be a problem. So as key takeaways, we can say that the best performance can be achieved using an LLM with a vector database, like the solution that we proposed, where all the terms of SNOMED CD were embeddings in the vector database, and the input of the LLM was the medical term and the embedding as well, after a reranking. The LLMs could replace or augment manual ontology curation, and future research should explore domain-specific fine-tuning, because we understand that when we fine-tune a model, a large language model in a specific domain, the results are better. Thank you for your time, and thank you for being here.
Yeah, thanks for your talk. I think it's a really nice approach to use LLMs in the age where they're upcoming. I was just curious if you've tried alternative, maybe more traditional no LLM approaches, like using, for example, OClip or some library to just annotate the terms with ontologies. And also, how do you behave in case of very general terms like age or sex? Because I can imagine that there are multiple different terms with maybe different, more granular, more niche meanings in the ontologies that you've mentioned. How do you pick one?
For the first part of the question, we used the BERT map as a benchmark. So we created some mappings with the BERT map. So then we compared these results with LLM, and the accuracy was very high for the LLM. And regarding the terms such as age, sex, etc., we created also a ground truth with the help of a doctor in order to be able to make to compare the results of the LLM. The evaluation of the expert did not include the accuracy of the mappings, or only the accuracy of not the accuracy, the final result, the graph, how it was constructed, and if it was valid, and etc. But as a next step is to extend the study in order to make a comparison between a benchmark and different LLMs, and see how they perform in creating a valid knowledge graph, as well as correct mapping to SNOMED CT or any other ontology.
Thank you very much for your presentation. So you state that scalability is an advantage of LLMs. I've also heard people say every time you send a query to an LLM, you burn a forest. So if you look at the energy consumption of an LLM and the scalability, as you state, what is your perspective on that? Have you thought about that? Have you worked on that as well?
There is a great variance between the LLMs that we tested. The results that we showed here was the results came from the use of the Claude Sonnet 3.5 v2 LLM, and we saw when we ran this study, it was the best LLM in terms of rankings. But it's something not objective. And we saw that incorporating different LLMs and even combining the results from different LLMs can give us the best possible results.